outside is frightful, but doing math is just so delightful. Since you got no place to go, let's find the slope, find the slope, find the slope. Hello, everyone, and welcome back to another episode with your girl, Mrs. Audrey Codner-Gibson from ACG Math Tutoring. All right, so hopefully everything is going all right. As normal, I am going to share my screen with you so we can get ourselves started. So today we are going to find the slope. So we're actually going to be using slope to find those parallel and perpendicular lines. So we're going to look at those Common Core standards, my AER.3 and my AEI.10. So we're going to be doing some simplifying and also some graphing. So before we get to that, let's look at the exit ticket from last time. So what is the slope of the line that passes through the order pairs 3, 2 and 8, 6? So we're going to do this algebraically. So if you recall, we had the formulas y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And that was our slope, which is represented by the letter M. Or, remember we had options, we can do y1 minus y2 over x1 minus x2. As long as the 1s and the 2s are lined up, and remember your y's are always going to be your numerator because it's your rise over your run. So since 3, 2 is the first point that I see, since we read from left to right, so this will be my x1 and my y1. So that means my 8, 6 is going to be my x2 and my y2, as you guys so lovingly call it. So let's plug it in. If I use my first formula, that means I'm going to have m equals 6 minus 2 over 8 minus 3. So 6 minus 2, that gives me 4. 8 minus 3 gives me 5. And since I don't need to reduce 4 over 5, my slope is going to be 4/5. Meaning I'm going to start at my y-intercept or my origin, wherever it may be, and I'm going to go up 4 and to the right 5 to make my next point. So for the next one, I'm going to use the other one, the y1 minus y2. So since 9, negative 6 is my first point, that's going to be my x1 and my y1. And negative 7 and negative 8, that's going to be my x sub 2 and my y sub 2. So I'm going to go from y1, which is negative 6, minus my y2, which is negative 8, over my x1, which is 9, minus my negative 7. So if you did it the other way, using the first formula, let's see if we get the same answer, okay? So don't change anything. So we have negative 6 minus negative 8. So when you minus a negative, it's actually turning positive. So you have negative 6 plus 8 over. Now we got 9 minus a negative 7. When you minus a negative, they turn positive. So you have 9 plus 7. So negative 6 plus 8, that gives me a positive 2. Okay, so since they're opposite, I subtract and I take the sign of my largest value. Then we have 9 plus 7. So that will give me my 16. So 2 over 16, that can be reduced by 2. So 2 divided by 2 gives me 1. And 16 divided by 2 gives me 8. So this is at its lowest form. So that means my slope is going to be 1 over 8. Wherever I start my y-intercept, I'm going to go up 1 unit and then go 8 in the positive direction, all right, to draw my next point. So if you said 4/5 and 1/8 for your slopes, high five, pound it, explode it, yes, go. All right, good job. So what we're going to do today, you're going to say to yourself, I can identify parallel and perpendicular lines using their slopes. So that's going to be our learning target for today. Yes, we're going to be doing some guided notes and some examples, and yes, we're going to practice, and we're going to finish this thing out with an exit. So what are parallel and perpendicular lines? What are they known for? So parallel lines, they're basically two lines that don't intersect. So if I can do this one, I'm going to try to draw it as straight as I can. And let's do this. Come on. And we'll have this line right here. Okay. So these two lines, parallel lines, they go in the same direction. They're either going to the left, they're going increasing, which is positive, or they're going decreasing, which is negative, okay? Or they can just be like two horizontal lines. But the key thing is parallel lines never intersect. The one thing that they do have in common is they have the same slope. Not the same y-intercept, but they have the same slope. So if I look at this, I'll go up 1 and over 1. So my slope for this one is going to be 1. For this one, I go up 1 and over 1, and this one also has a slope of 1. But notice where they cross the y-axis. This one crosses the y-axis roughly around 4. That's what I was shooting for. And this one crosses the y-axis at 0. So the y-intercepts are different, but their slopes are exactly the same. So now let's look at perpendicular lines. So perpendicular means we got two lines that intersect that creates a 90-degree angle. Look at us doing a little bit of geometry, kind of flashing it back. So they're actually going to have slopes that are what's called opposite reciprocals of each other. Reciprocal is just another name of saying flip, okay? We're just going to flip things out. Hopefully I'm not throwing up gang signs. I'm just really trying to show the flip, okay? So if I gave you 1/3 and it's a positive 1/3, so that means the opposite of positive would be negative. And then in order for me to show the reciprocal, I need to flip them. So that means the 3 that was on the bottom, the denominator, is now going to be up top, the numerator. And then the 1 that was up top, the numerator, is now going to be down the bottom, the denominator. So basically, opposite reciprocal of 1/3 is -3/1. So now this part right here, where I said product is equal to -1, that means if I multiply those two ratios together, I should get a -1 to show or to prove that they're opposite reciprocals of each other. So if I multiply these two, I'm going to get a -3/3, and -3 divided by 3, that gives me my -1. So they are definitely opposite reciprocals of each other. So if I wanted to have a slope of 1/3, so say if I start at the origin, I'll go up 1 and over 3. So that means my first point should be here. So this would be my line for that one. And let's say for -3, just to give it a different starting point. If I start at 4, I go down 3, 1, 2, 3, and then over 1. And I'm going to try my hardest. Oh, look at this, I'm getting better. So if you can see right here, this is going to create that 90-degree angle, okay? So if the lines have, and if you can see it with the graph, but remember, with math, we always got to prove it, okay? So for parallel lines, they have the same slope. Perpendicular lines have opposite reciprocals, all right? So let me show you through examples. So we got two lines here. We have line 1 and line 2, and we have 2 points that's associated with each of those lines. So what we need to do to prove is it parallel or perpendicular, we have to find the slope of both of those lines. So we could go ahead and graph these lines. So I got 4, -2. So if I start at the origin, I go to 4 and then -2. Okay, so that's that point right there. And then -3, 5. So we go to -3 and then we go up 5. And then we're going to draw our line. Okay, so this one is going to be line 1. So now for line 2, we got 2, -5, which is this point here, and then 1, -4, which is this point here. And then we try to draw our line. I love how I tilt my head when I draw my lines. It's hilarious. And then this will be line 2. Just by looking at the graphs, what do you notice? Those two lines are not intersecting. So since they're not intersecting, they should be parallel lines. But what happens if they don't give us a graph? What are we going to do? If I'm going to use slope, that means I'm going to go to my equation. My y1 minus my y2 over my x1 minus my x2. Okay? So I need to find the slope of both of my lines. So I'm going to use that first line. So these are going to be my x1s and my y1s. These are going to be my x2s and my y2s. So we are going to have -2 minus 5 and -3, -4, we got 4 minus -3. So let's cut that. So let's start. We have our -2 minus 5 over my 4 minus -3. So -2 minus 5, that gives me -7. And when I minus a negative, they turn positive. So 4 plus 3, that will give me 7. So it gives me my slope of -1. So that's all we have for line 1. So we're going to do the exact same thing, but for line 2. So we have my y1, which is -5 minus -4 over 2 minus 1. So when you minus a negative, they turn positive. So I have a -1 over 2 minus 1 gives me 1, which reduced will also give me a -1. So since both of my slopes are exactly the same, that proves that we have parallel lines. Let's go for the next one. So we have our equation. I'll switch it to the y2 minus y1. I just like to switch it around sometimes, because you should get the same answer regardless. So for line 1, we're going to have my y2, which is 3 minus a -6 over 4 minus 7. So when you minus a negative, they're turning positive. So you have a 9. And 4 minus 7, that gives me my -3. But 9 divided by -3 can be simplified. Remember, when you see fractions, you are basically doing division. So we have a slope of -3 for that line 1. So now we're going to try to find what line 2 is. So if I want, I can say 1 minus 2 over 4 minus 7. So 1 minus 2 gives me a -1. 4 minus 7 gives me a -3. Now, a negative divided by a negative, that will give me positive. And then I will still have my 1/3. So we have a slope of -3, and we have a slope of a positive 1/3. Both of them are opposite. One's positive, one's negative. And it's a reciprocal. Remember, 3 over 1 flipped will give me 1 over 3. So these are going to be perpendicular lines. We can graph it. So if anything, we got our 6, -6, and our 3, +3. So this is going to be one line. Then we have our 7, 2, and our 4, 1. And this is going to be our other, our other line. So sorry. And this is going to be our other line. So if I drew it with a ruler, this will be completely straight, which does give me a 90-degree angle. So these are definitely perpendicular lines. All right. So you want to take a look at the slopes. If the slopes are the same, it's parallel. If they're opposite and you notice that they're flipped or reciprocals, they are perpendicular. So let's get with the practice. Do we have parallel or perpendicular lines? So we can find our slopes, or we can go ahead and graph them. So let's find our slopes first. So we can do our y2 minus y1 over x sub 2 minus x sub 1. So for first line, we have a negative 4 minus 1 over 4 minus 8. So this will give me a negative 5 in my numerator, and this will give me a negative 4 in my denominator, but a negative divided by a negative will give me a positive. So the slope for the first one is a positive 5/4. So it gives you a rise of 5 and a positive run of 4. So now if we want to find the slope of the second line, using the same formula, okay? So remember, these are going to be your x1s and your y1s. These are your x2s and your y2s. So my y2 is 0 minus 5, and then we have 6 minus 4. So 0 minus 5 gives me negative 5. 6 minus 4 gives me 2. And that means we can keep this. We don't have to reduce it, and we can't reduce it. But what do you notice? They're not the same. One's positive, one's negative. They're opposites. That's true. But are they reciprocals? No. So this case, it would be neither. See? Just because I give you two options, there's always a third option. There's always that, yes, both of them. Well, obviously, both of them can't be parallel and perpendicular, but there's a way that you can still have lines intersecting that's neither parallel or perpendicular, okay? So if you want to see it, we got 8, 1, which is right here, 4, negative 4, which is right here, drawing our line. Maybe a little bit better. Then we have 4, 5, which is right here, and 6, 0, which is right there. And we're going to draw our line. And yes, they intersect, but they definitely don't give me that 90-degree angle. So they're neither parallel or perpendicular, they're just intersecting lines. So going with our exit ticket, so we're kind of looking at parallel and perpendicular lines. You got two lines. Follow along what we just did to kind of help us out. So like always, you guys are doing awesome. You know, it's going to get a little more challenging as we progress on. But if you do it step by step, you'll be able to achieve whatever goal you want into understanding these concepts so you can apply it to whatever assessment that you need to take. All right, so as always, this has been a pleasure. Hopefully you guys are doing all right. Sorry for the singing, but it's kind of fun. All right, so I will see you guys next time, and take care of yourselves. Bye.